Hello and welcome to another digital design class. In the previous class, we spoke about complements and we solved some practice problems, some problems on the diminished radix complement and the radix complement. Today we will continue with the complements. I would show you another way to solve the complement problem and how to find a complement of a binary or a decimal number. And then we will start with subtraction. How we can subtract binary and decimal numbers using complements, the radix complement. So we learned if we want to find r minus 1 or 1's complement, for example, or for the base of 2, what we do is simply we would change all our zeros to 1's and all the 1's to 0's. And this would be our 1's complement. And simply to find the 2's complement, I would add 1 to this. And for example, in this particular case, already as mentioned here, 1 plus 1 gives us 0, 1, 1 plus 1 gives us 0, 1, 1 plus 1, 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 0, 1, and 1 plus 1. If we want to add them together. And you can see that everything would become what? 0. Now, another way to find the complement, if we want to find the radix complement or the tens complement for a decimal number, for example, here we have a number 0, 1, 2, 3, 9, 8. What we do, we subtract the least significant non-zero digit from 10, and then we would subtract the rest from 9. So in this particular case, 0, 1, 2, 3, 9, 8, the last number, least significant number is 8. We will subtract that from 10, we get 2, and the rest of it, we will subtract it from 9. So the rest of it is going to be 9 minus 9 is 0, 3 minus 9 is 6, 2 minus 9 is 7, 1 minus 9 is 8, and 0 minus 9 is 9. So if I just want to find the 9's complement for this, 987602, the 9's complement for this is going to be subtracted everything by 9. So this would be 7, 9, 3, 2, 1, 0. Am I correct? So this is the 9's complement of that, the upper number. Now, what happens if I add 1 to it? It's going to be 8, 9, 3, 2, 1, 0. And you can see that these two numbers are the same. So two ways. You can rather find the 9's complement, add 1 to it, or the other way is the least significant number, you subtract it by 10. Rest of it, you will subtract it by 9. This is the easier way to do it. Now, you may ask, what if the least significant number is 0? So for example, if I want to find this 4890, I want to find the 10's complement for this. Obviously, if you subtract 0 by 10, what are you going to get? 10. You can't put 10 here. So in this particular case, what you're going to do is you would just leave the first 0. You would just transfer that. And the second number, you would subtract it by 10. So 10 minus 9 is going to be 1. And the rest of it, you would subtract by 9. So this is going to be 1, and this is going to be 5. So 5110 would be the 10's complement. Now let's find it the way that we did before, 4890. Let's find the 9's complement for this. The nines complement for 890 is equal to what? 9, 0, am I correct? 1, 5. And when I add 1 to this, what do I get? Which is exactly the same as the previous. What if I have 2 zeros? I would leave those 2 zeros and jump to the first non-zero digit. So the tens complement for 2, 4, 6, 7, 0, 0. Again, we would keep the least significant zeros unchanged. And then we would subtract the least significant non-zero digit from 10. And then we would subtract the remaining digits from 9. Is it clear? Do you want me to solve a practice problem? Okay. Give me a 6, 7 digit decimal number.
No decimals.
No decimals, no.
531
531
782 0
531 7
70.
7820. So we want to find the tens complement for this. I'll give you a few minutes to think on it and I'll solve it. What is the answer?
462
2180. Yes, that's correct. So the first 0, we would just leave that. Second, the first non-zero digit, we would subtract it by 10. We're going to get 8. And then the rest, we would subtract it by 9. So it's going to be 1, 2, 8, 6, 4. What if I add these two numbers together? What if I add these two numbers together? Because it's a tens complement, I'm going to get all of these would be 0. At the end, I'm going to have a 1. If it was a nines complement, everything would be 9. Because it's a tens complement, everything would be 0. So as you remember, for a binary number, the radix and the diminished radix complement, or the 1 and 2's complement. For the 1's complement, we would replace the zeros with 1s and 1s with zeros. That was easy. For the 2's complement, there is another way. It's the same as what we did for the decimal numbers. And in this is an example. For a binary number, we would keep the first zeros, the least significant number zeros, and the first one, and everything else, we just change the zeros with ones and ones with zeros. So we would replace the zeros with ones and ones with zeros for everything else. Or in other words, we will find the ones complement for everything else. Let me give you another example. 1, 0, 1, 0, 1. What is the 2's complement for this? So we would keep the first one, and all the ones become 0, and all the zeros become 1. I can test it. Let's test it, okay? First, let's find the ones complement. It's gonna be 0, 1, 0, 1, 0. And when you add 1 to it, it's gonna be 0, 1, 0, 1, 1, which is the same as this. Okay. And if you add these two together, what are you gonna have? Everything would be 0, and at the end, you're gonna have a 1 to test and see if we got it right. Now, let's find the 2's complement for this. What is the 2's complement for this number? 1, 0, 0, 0, 1, 0, 0, 0, 0, 0. We want to find the 2's complement. Obviously, the 1's complement is easy. You just replace zeros with ones and ones with zeros. What is the answer?
0, 1, 1, 1, 1.
No.
The 0, 1, 1, 1, 1, 0, 0, 0, 0, 0.
Yes, you would keep all these zeros in the first one. So it's going to be 0, 0, 0, 0, 0, 1. And then the rest, the ones are replaced with zeros, and the zeros are replaced with ones. So it becomes 0, 1, 1, 1, 1, 1, and 0, 0, 0, 0, 0. And if you add these two together, you would see that it becomes all zeros and it has a carry, which we discard. I'll give you a minute to solve this one. We want to find the 2's complement for this. 0, 1, 1, 0, 1, 1, 1. And also for this one, let me give you another one. And 1, 0. So for these two numbers, we want to find the 2's complement and the 1's complement. Did you all solve it or you need more time? I'll give you another minute. Okay, so the ones complement is easy. You just replace the zeros with ones and ones with zeros. So what is the ones complement for the first one? Can someone read it to me? The ones complement for this one, the first one, the one on the left. Perfect, 1 0 0 0. Thank you. And what is the twos complement? We would keep the first one, the least significant one, and the rest is going to be at basically the ones complement. We will replace the zeros with ones and ones with zeros. So the answer would be 1 0 0 1 0 0 1. And if we add 1 to the first complement, you would see that we get this second, or the twos complement. Now the twos complement for the second one, we will keep the first zeros and the first one, and the rest is going to be replaced. And the ones complement is going 1 1 1 0 1 0 1 1 0 1 1 1. Now if I add 1 to this, 1 plus 1 is going to be 0 1. 1 plus 1 is going to be 0 1. 1 plus 1 is going to be 0 1. So I'm going to get 1 1 1 0 1 0. And you can see these two are exactly the same. Am I correct? Yes. Okay. This is another example. The twos complement of 0 1 1 0 1 1 1 is 1 0 0 1 0 0 1. So what we do, we would keep the least significant zeros and the first one unchanged, and then we would replace the remaining zeros with ones and ones with zeros. Now that we learned about complements and the twos complement, how can we use that for subtraction? So subtraction with complements. If we want to subtract two numbers like m and n, m minus n, in the base of r, what we would do, we would add the minuend m to the r's complement of the subtrahend n, and mathematically would be m plus r n minus n, or n minus n plus rn. Now, we would have a couple of scenarios. Scenario number one is that if m is greater or equal to n, then the sum would produce an n carry, or rn, and we would discard that. And what is left is the result of m minus n. But if m is less than n, then it doesn't produce an n carry. Therefore, the result would not be our final result, and we have to find the complement of that number. And that would be our final result. And this applies to any base number, base of 10, 8, 16, 7, 4, 2, binary. You can solve just using these basic principles. And so again, we would have two situations when we add the first number to the complement of the second number. First scenario is the first number is greater than the second number. We're going to have a positive answer. Therefore, when you solve it, you're going to have an end carry and you're going to discard it. But if you add those together and you don't get an end carry, that means your number is a negative number. Therefore, the result is not our actual result, and we have to find the complement of that, and that's going to be our end result, which is a negative number. Now, let's go through some examples. I think it's easier to learn with these examples. We want to use the tens complement to subtract 72,532 minus 3,250. So how many digits does the first one have? 5. How many digits does the second one have? 4. So the first thing that we do, 72,532 minus 3,250. We would add a 0 on the left, okay? Because both of them, we have to have the same number of digits, okay? Now, to do this, I'm going to add the first one, which is 72,532, to the complement, the tens complement of the second one. So what is the tens complement of 3,250? Again, we would keep the first 0, the least significant 0 on the right. We will subtract the first digit by 10. So I'm going to have 5. And then I'm going to subtract the rest by 9. So second one is going to be 2 is going to be 7, 6, and 9. Now I'm going to add these two together. So 72,532 plus 96,750. The result would be 169,282. So as you can see, we have added two 5-digit numbers and the result is a 6-digit number. So what we do is we will simply get rid of the end carry or the last digit on the left, and the answer will be 69,282. And you can use your calculator to double check as well. So please subtract 72,532 minus 3,250. Okay. Did you get the same result? Okay. Now we want to do it when the first number is less than the second number. So we want to do it the other way around. We want to subtract 3,250 minus 72,532. Obviously, as you know, this is going to result in a negative number. So we would keep the first number digit and add a 0 up to the left to have same digits. The second one, 72,532. If you want to find the tens complement, we would keep this. We would subtract the first digit from 10, gives us 8, and the rest from 9, gives us 6, 4, 7, 2. Now, if we add these two together, we would get a sum of 30,718. And as you can see, both of them are 5-digit numbers and the result is 5-digit. We don't have any end carry. And since we don't have any end carry, this is not going to be our final answer. Our final answer is going to be negative of the complement of this. So what we do, we would find the 10th complement of 30,718. First digit is subtracted by 10, gives us 2. Second one from 9 gives us 8, 2, 6, 9, 6. And we will put a negative sign in it. So this is the tens complement of it. Therefore, the answer is going to be the negative tens complement of 30,718, which gives us negative 69,282. Is it clear? Yes? Okay. Now, for a binary number, we would do the same procedure. We would keep the first number, and then we would add it to the 2's complement of the second number. In this example, first number x is 1 0 1 0 1 0 0, and y is equal to 1 0 0 0 0 1 1. So the 2's complement for y, we would keep the first one on the right, and we would flip or change, replace all the zeros with ones and ones with zeros. And what we get is 0 1 1 1 1 0 1. When we add them together, we have two 7-digit numbers, and what we get in the summation, we get an 8-digit number. We have an end carry. What we do, we would discard the end carry, and then the answer would be the rest of 7 digits. So 0 0 1 0 0 1. Now, what I want you to do as an exercise is find the decimal equivalent of x and y. I want you to find the original x and y. I want you to find the decimal numbers for x and y, converted from binary to decimal. Does anyone have the answer? What is x equal to? Thank you. Just give me this. And what is y? 66 or 67?
67.
It can't be 66. It must be an odd number, not an even number. If it's an even number, it would end with a 0. When it's an odd number, I'm sorry. Yes, when it's an odd number, it ends with a 1. So 84 minus 67 gives us 17. Am I correct? And what is 1 0 0 0 1 equal to? It's 2 in the power of 4 plus 2 in the power of 0, which is 17. Am I correct? Yes. So we have checked it and it works. Now let's do y minus x. Okay. So we would keep y, which is 1 0 0 0 0 1 1. And this time we will find the 2's complement for x. The 2's complement for x, we would keep the first 3 digits, and everything else would be replaced with. So this is going to be 0 1 0 1 1 0 0. Just down here. When we add them together, we won't have any end carry. Therefore, we would find the complement of the answer, which is 1, 1, 0, 1, 1, 1, 1, 1. And that will be our final negative. That number will be our final answer, which here again is going to be 67 minus 84, which is negative 17 this time. And this is equal to negative 70. Is it clear? Yes. So what a computer can do is basically by just using the complement system, you can subtract any two numbers, which is great. You don't need multiple, gates. You just need one sets of gates and you can subtract or multiple two numbers. Now, let me give you some practice problems. I want you to subtract 1, 1, 0, 1, 0, 1, 0, 0 minus 1, 0, 1, 1. I will give you a few minutes to think on this. And let's do another one. 0, 1, 0, 0, 1, 0, 1, 1, 1 minus 1, 1, 0, 1, 0, 1, 1, 0. I will give you 7 or 8 minutes to solve this. Did anyone solve it? Do you need more time? I'll give you a few more minutes. Does anyone have the answer for the first one?
One, 0, 0, 1, 0, 0, 1.
Just give me a second to. Again, what was it? One? This is for the first one, yes? If I convert the first one to decimal, what would it be? It's gonna be 212. You can double check it. And the second one is gonna be 11. 8 plus 3 is 11. So the results, if you want to do it, it's going to be 201. Yes. Okay, now let's do it in the binary. I just want to show you this so you can double check it at the end. So we're going to keep the first number, and then we want to find the 2's complement of the second number. How many digits do we have? 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now I would find the 2's complement for this. The 2's complement. The 2's complement for this is going to be 1. I'm going to keep the first one, 0, 1, 0, 1, 1, 1, 1. Okay. Now what I'm going to do is add that to this first number. So 4 1s and then 0 and then 1, 0, 1. Now if I add these two together, it's going to be 1, 0, 1, 0. 1 plus 1 is equal to what? 1, 0, 1, 0. 1, 0. 1 plus 1. 1, 0. 1 plus 1 plus 1 is going to be what? 1, 1, 1. 1 plus 1 plus 1 is going to be 1, 1. We will discard the last one, and this is going to be ours. Now, if I convert 1, 0, 1, 1, 0, 0, 0, 1, 0, 1 to I'm going to get that same result. And please double check that.
Is 1 plus 1 is 1, 0, right?
Has been a mistake here. Yeah. What is the problem? Which part would you do wrong?
So the third one plus 1 then? Yeah.
Yes, sorry. It's this. Yeah, 1 plus 1, we have 1, 0. Thank you. Yeah. And if you check this, it's gonna be 1, 1, 0, 0. I was double checking it. That's the reason it took a little time. So 1, 0, 0. So again, this is 11. This is 202. And this would give us 201.
Maybe a third one at the front, because it's 1, 1, 1. That's 1.
Which number are you talking?
At the very front of after you've added it all together, the 3 1s equals 1, 1. Steps down. So it should be,
The one on the left?
yes, should there be one extra one on the left?
Yeah, it is. And because it's an extra end carry, you just discard it. Yes, and you could see that I took it off. It's this one. Okay. So it's the last one. Let me do it with a different color. So the last one, because it's let me do it with a different color. My pen doesn't change color. for some reason. So this is the end carry, and what we do, we would just discard it. Okay, I'm sorry, my pen doesn't change color for some reason, but this end carry, you would just discard it, okay?
Oh, okay, you crossed it out, and I thought it was like a.
Yeah,
I
a
was-
star,
yeah.
yeah, I figured that out, I'm
Yeah.
sorry, yeah, because, yeah.
I was like, what in the world?
Yeah, thank you for mentioning that. Again, I don't know, my pen doesn't work for some reason. So this one we have to discard. Okay. What about the second one? What did you get for the second one?
I got 1, 1.
So if I convert this to decimal, this would be 151, the first one. And the second one would definitely be greater than the first one. So 110, 10, 110 would be equal to 214. So we're gonna have a negative number over here. So first thing we're gonna do, we will find the 2's complement for the second. And what was your answer? I'm sorry for interrupting. What was your answer?
It was negative 0, 0, 1, 1, 1, 1, 1.
So all ones?
Yes.
How many ones? 4 or
6.
6? Okay. Yep. Yeah. That's correct, I think. Yeah. Because it should be 63. And yeah, 6 ones gives us 63. If I had 7 and 1 and 6 zeros, it will be 64. So this is 63. Okay. So the second number, we would find the complement, the 2's complement. This would be 0, 1. So we keep the first 0 and the first 1. And then the rest is going to be replaced, all the zeros with 1s and all the 1s with 0s. Now we would add the first number to the complement of the second one. There's going to be 0, 0, 1, 0, 1, 0, 1, 0. Am I correct? Okay. It's too many 1s and 0s, I get confused. I don't know if about you, but 1 plus 0 is 1. 1 plus 1 is 1, 0. 1 plus 0 is 1, 0. 1 plus 0 plus 1 is 1, 0. 1 plus 1, 1, 0. 1 plus 1, 1, 0. 1 plus 0 plus 0 is 1, and 1 plus 0 is 1. So as we can see here, we don't have any end carry. Therefore, we know that this is not our correct answer, and we have to find the 2's complement. And the negative of this 2's complement would be our answer. So to find the 2's complement, we would keep the first 1, and the rest would be just replaced by zeros with 1s and 1s with 0s. So we would keep this 1, and the rest would be 1, 1, 1, 1, 1, 0, 0. So we would have 6 1s, 1, 2, 3, 4, 5, 6, and 0, 0. So 151 minus 214 gives us negative 63. And if you can see, this is also equal to negative 63. If you have 6 1s, it's negative. It's 63. And you have a negative in front, so negative 63. Do you want me to solve another one, or we can go to the... Do you want me to solve another one? We can do a decimal number if you like. Want to do a decimal number? Okay. Okay, now it completely stopped working. Now, let's do this one. 1, 2, 3. Oh no, 1, 2, 6. I have an example here. 1, 2, 6, 3, 2, 7, 7. We want to subtract that from 3, 5, 6, 9, 5, 3, 1. So 1,263,277 minus 3,569,531. I want you to solve this using the tens complement. First find the tens complement of the second number, then add the first number to the tens complement. By the way, I haven't put a date for the first and second midterm exams because I don't want that to, interfere with your other exams and classes. Let me know when you want to take your first exam. The first exam would be probably at the end of September. Let me know when is a good time for you. Do you want to take it like on Tuesday or Thursday? Do you have any exams on Thursdays? It's gonna be the same time as the class. But before that, we're gonna have a review session. Please check your other exams and other classes and let me know when is a good time for you to take, do you want to take the exam? For the online students, it's gonna be different, that the exam is gonna be during weekends and they have a window to take it, but for you, let me know when you wanna take this. And again, your first set of homeworks would be posted this weekend on Friday, and you're gonna have 1 week, you have actually 10 days. From this Friday until the next, not next Monday, next Monday, to submit your homeworks. Did anyone solve? What is the answer?
1,200.
Yes, perfect. So the first step we want to do is we want to find the tens complement of the second number. So finding the tens complement, we will subtract the first digit by 10, gives us 9. And the second one from 6, from 9 gives us 6, 4, 0, 3, 4, 6. And if we add these two together, so tens complement is going to be 6, 4, 3, 0, 4, 6, 9. Two ways to find the tens complement. One way, as I mentioned, the other way is to find the nines complement, add 1 to it. So when we add these two numbers, the first number and the complement of the second number, we get 693,746, which again, we don't have any end carry over here, so this is not going to be our answer. We have to find the twos complement for this. I'm sorry, the tens complement. The tens complement for this, which is going to be 2,306,253, which is going to be negative of this number would be our answer. So the negative would be negative 2,306,254. Is it clear, or do you want me to solve another one? Okay. So I mentioned that we can use the r's complement. We can also use the diminished radix or the r minus ones complement to find the subtraction as well. So subtraction of unsigned numbers can also be done by means of the r minus ones complement or the diminished radix complement. Remember that r minus ones complement is 1 less than r's complement, the r's complement. So for this example, we will repeat the previous example. Again, when we repeat that, we get the sign of the sum would be equal to 1, 0, 0, 1, 0, 0, 0, 0. We have an end carry that we would get rid of. We would discard the last one on the left. And the only difference is we would add 1 to it, and this would be our final answer. So we would simply find the ones complement, which is easier, and then at the end we would add 1 to it instead of finding the twos complement. And it's also the same when the second number is greater than the first number. So again, we're going to find the y's first complement or ones complement, which is going to be, I'm sorry, we will keep y and find x's ones complement, and x's ones complement is going to be equal to 0. If we want to find, sorry, x 0, 1, 0, 1, 0, 1, 1. This is going to be, which is exactly this one over here. And when we add them together, we don't get any end carries. And what we're gonna do this time, we're gonna find the ones complement of this number, and that would be our negative number. This is an example for the twos complement that I solved for, and we already solved an example for the twos complement. So we can do it both with the r's complement or r minus ones complement. So the reason that I kept this here is I want to show you something. So for a negative number, we see a negative sign in front of a binary number. The computer doesn't understand any signs, any words, anything, any letters. It only understands zeros and ones. The computer only works on voltages. It doesn't understand what X means, what Y means, what A means, B means, negative, positive, exclamation mark, question mark. It doesn't know what any of these mean. So you have to allocate a bit to the computer to understand what a negative positive sign means. Okay. So to do that, we have what we call the signed binary numbers. And for example, we will allocate the binary number 1 for a negative and 0 for a positive.
So just keep the number the same.
Yes, so the number on the left, the first digit on the left is actually going to be the sign bit, what we call a sign bit. It's not part of the number. It's the sign of that number. And I'll give you some example. So if I have a number like 1111, if this is a number, this would be equal to 7. Yes. But if I have a sign bit and I have 111, then the first one is the sign for negative, and 11 is equal to 3. So these two numbers are not equal if this one is a signed number. Okay, this one is equal to 7, this one is equal to negative 3.
We allocate that, right?
So we would usually mention that this is a binary signed number, okay? And the computer actually knows. We would tell the computer that the first bit, usually when we send that, it's a separate bit that we send after the number, and it's in a different flip-flop, and I would explain this later on, but it's in a different, spot, and the computer knows that this sign number is, this bit is sign number. And actually, when we send 111 to the computer, always there is a bit what we call the sign bit, that's 0, and we get 111, okay? And for the other one, you know what I mean? That one is actually going to be, so the other one actually is going to be 1. The sign bit is always, a separate bit that is allocated. So to represent negative integers, we need a notation of negative values. It is customary to represent the sign with a bit placed in the leftmost position of the number since binary digits. The convention is to make the sign bit 0 for positive and 1 for negative. And these are some examples. So sign magnitude representation is going to be 1 0 0 0 0 1 0 0 1. And the ones complement, as you can see, we have flipped all the digits but the last digit on the left. Okay, we kept that because that is not part of the number. That is our sign bit. Okay, so when we complement it, we're going to change that. And this table actually lists different binary numbers with their twos, complements, and their signs. So you can see positive 7, it's going to be 0 1 1 1 1, and so on. And the ones complement and the signed magnitude. And you can see here, for example, 0, negative 0, positive 0 is going to be 0 0 0 for the ones complement and 1 1 1 for the negative ones, for the ones complement for negative 0, which basically both of them are the same. So let me give you an example. Imagine I have 1 1 0 1 0 1. And I tell you that this one is my sign bit. What is this equal to? And what is this equal to? 0 1 1 1 0. And I tell you that the first bit is my sign bit. Perfect. Yes, the first one is what? This is negative and this is 9. So it's going to be negative 9. And what about the second one? Positive what? 14. Thank you. So if everything was 1, it would be 15. You minus 1, it's going to be 14. It's an easier way to find it. So negative 9 and 14. So for arithmetic addition, the addition of two numbers in the signed magnitude system follows the rules of ordinary arithmetic. And if the signs are the same, we add the two magnitudes, and given the sum, the common sign. So if we want to add like 6 plus 10, 5 plus 4, something like that, and both of them are positive, we would just simply add them. If we want to do -6 minus 4, both of them are negative, so we would add them. It's going to be 10, and we will assign the common sign for them. If the signs are different, we subtract the smaller magnitude from the larger and give the difference the sign if the larger magnitude of the larger magnitude. The addition of two signed binary numbers with negative numbers represented in the signs 2's complement form is obtained from the addition of the two numbers, including their obviously sign bits. A carryout of the sign bit position is discarded. So these are some examples. If we want to add +6 to +13, we can simply add them, and the result obviously is +19. Now, if I want to add -6 to +13, what is 6 equal to? Can you tell me in binary?
110.
110 is equal to 6. Am I correct?
Well, are you wanting positive? It'd be like 0, 1,
Yes.
0.
No, +6 is, yeah, 110. 6 is 110. Okay. And if I add a 0, it's obviously +6. So imagine I have a 1, 2, 3, 4, 5, 6, 7, 8 digit. 1, 2, 3, 4, 5, 6, 7, 8. Now, what is -6 equal to? If I want to find its complement. So if I want to find the complement of this number, I would simply keep the first 0, keep the first 1, and the next is going to be like this. Am I correct? So this is going to be -6. And as you can see, the last digit is also 1. So here I've actually found the 2's complement of 6. So the 2 complement of 6 is going to be, the last 4 digits are going to be 1, 0, 1, 0. And if I add that to 13, +13, which is 0, 0, 0, 0, 1, 1, 0, 1, gives us 7, which is 0, 0, 0, 0, 0, 0, 1, 1, 1. When I add -16 to -13, again 13, +13, is 0, 0, 0, 0, 1, 1, 0, 1. And if I find the complement of 1, 1, 0, 1, keep the first one, flip the second and third, and the rest of the ones would be kept.
So the 2's component is normally the opposite sign of the one cap. Basically, is that what you're saying?
Yeah, yes, yes. And we just have to find the complements. And you can see that the complements match the sign bit sign number as well. So when it's negative, you had the last number is 1 on the left, and when it's positive, it's going to be 0. Now, this is an example of subtracting two numbers. This is an example of subtracting two negative numbers. Again, this is the 2's complement of 6, which gives us -6. And this is the 2's complement of 13, which gives us -13. And if I add them together, -16 minus -13, you can see that it gives us, I can find the negative of the negative of negative is going to be positive. Am I correct? Yeah. So I have to add -6 plus 13. And what is plus 13? Plus 13 is the complement of this again, the 2's complement, which gives us 0, 0, 0, 0, 1, 1, 0, 1. And adding those two gives us +7, which is 0, 0, 0, 0, 0, 1, 1, 1. Now I want you to find, I will solve a practice problem and then that's gonna be for today. Negative seven minus negative 8. And you can write 8 like negative 7 like this. 1, 1, 1, 1. This is negative 7. Oh, let's just use a binary solution to solve this. Negative 7 minus negative 8. I want you to solve this. What is the answer for this? In binary, just do it in binary. I forgot to mention, I want you to do it in the 2's complement. And you can see just step by step. You would take the 2's complement of the subtrahend, including the sign bit, and add it to the minuend, including the sign bit. The carryout of the sign bit position is common. You can just follow this and make it 8-bit. The 8-bit. 2 8-bit numbers. If you want, I can go back as well. Did anyone solve it? Do you want me to solve it? So what is 7 equal to if I want to put it in an 8-bit system? It's going to be 1, 2, 3, 4, 5, 1, 1, 1. Am I correct? What is this? Now I want to find the complement of this. If I want to find the complement of this, what is the complement of this number? 1, 0, 0, 1, 1, 1, 1, 1. Am I correct? So this now is going to be negative 7. Now let's find 8. What is 8 equal to? 1, 2, 3, 4, 1, 0, 0, 0. Am I correct? Yes. This is equal to 8. What is negative 8? It's going to be 0, 0, 0, 1, 1, 1, 1, 1. This is going to be negative 8. We didn't even need it to do that, but I'm going to do it anyway. So it's going to be 1, 1, 1, 1, 1, 0, 0, 1 minus 1, 1, 1, 1, 1, 0, 0, 0. So this is going to be -7 minus -8. Now to subtract these two, again, I have to find the complement of this. So it's going to be 1, 1, 1, 1, 1, 0, 0, 1 plus the complement of the second one, which is going to be 0, 0, 0, 1, 0, 0, 0, 0, which is 8 technically. Now if I add these two, this plus 0, 0, 0, 0, 4 zeros, 1, 0, 0, 0, I get 1, 0, 0, 1 plus 1 is 0, 1, 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 and 1 plus 1 is 0, 1. The last one I discard. And what am I left with? -7 minus -8 gives us 1. I would solve more practice problems on the sign bits next week. Again, I will solve the first set of homework this weekend. Please let me know if you have any questions, and when do you want to take the first midterm exam? And I will see you next week. Thank you so much.
Why do we go out to 8 digits in this process?
That's a great question. So the reason that we go